Once upon a time, there was an equation of an ellipse. All right, can you tell me what the center is?
0, 0.
No.
Negative 2, 5.
Negative 2, 5. Thank you.
Oh, wait.
Oh, man. Gonna have to zoom in on this. Give me the A value. 3, right? Square root of 9 is 3. B value. 7. Square root of 49 is 7, right? Okay.
After that, I don't know what else to do. I'm done.
Well, you're not done after that. Okay. All right, so you said negative 2, 5. Yes, indeed. Okay, there's my center. How far to the right do I go and left do I go? 3 units. Okay, so that would be over to here. And then over 1, 2, 3 this way. Whoa, that does not look proportional. Oh well. How far up and how far down do I go? 7. Okay. 1, 2, 3, 4, 5, 6, 7. Okay, 1, 2, 3, 4, 5, 6, 7. And so now I have my imaginary ellipse, my box. Sorry, I got off on that little dot there. Where is the ellipse in relationship to this imaginary box? Inside the box. Okay, so what do we need to know? We need to know things like vertices. It went up 7. The B value is 7. And we went down 7. We went right 3 and left 3. That's your A value. I don't like this game. All right, now we know that, so give me my vertices. They would be at the end of the major axis. Negative 2 is one of them. That's true. You went 7 units down from negative 2, 5. So if you go 7 units above 5, negative 2, 12. That's true. That's only if the major axis is horizontal. Yes. That's why they call it major. Is the major axis the longer one? Yeah, and the answer is definitely yes.
Wait, where'd you get the vertices from again?
We counted up 7 and down 7 from the center. You see the center, negative 2, 5?
Yeah.
We went up 7 and found negative 2, 12. And we went down 7 and found negative 2, negative 2.
Vertices are
Correct, but at the end of the major axis. You're correct, it's where it curves, but at the end of the major axis. Okay, now we need to get the foci. So we need the distance C, which we know that C squared is the absolute, it's the, not C would be the would be the square root, sorry, of the absolute value of A squared minus B squared. Yeah, 49 minus 9. If you pay attention, that means 49 is B squared. So we had to throw in the absolute value because we don't know which one's bigger. It doesn't really matter because you're doing the absolute value. Okay, so we've got the square root of 40, right? Which is approximately what value? What is, that's like 6 point what? 6.3? Come on, square root of 40, somebody. You got a calculator, for crying out loud. Actually use it. Guys,
6.3.
okay, there we go. 6.3.
What did you say?
Okay, so foci. Yes? So negative 2 what? What are you doing with this distance? You're going up 6.3 units. 11.3 units. Yes, 11.3 would be the one of them. And then negative 2 what? 6.3 units down. It has to be along the major axis, folks. Whatever 5 minus 6.3 is. Oh, negative 1.3. You must be able to find the value of C and use it along the major axis to find the foci. Yes. Well, we were at the center and we went up 6.3. That would have been 5 plus 6.3. That's how we got that one. Oh, that's right. Okay. I did record it, but I can't remember if I actually got it posted. So I'll check on that during lunch. We'll get it posted if it isn't. Are you a subscriber? Okay. Okay. Yes.
Actually, we need this daily content.
Yes.
The daily Staileys.
Yep.
Yeah.
At least that's what
All right. There we go. Okay. Next. Okay. Eccentricity. Okay. Eccentricity is a measurement of, I'm going to write this out here. Distance to focus over distance to vertex. Now, I spelled it out for you in that way for a very particular reason. Do not get hung up on this definition, C over A, because it could be C over B. Now you're saying, well, why could it be either one of those? Remember, the book's definition is that A is always bigger than B. I have always said that A squared sits underneath the X term. So A goes with X. So I need to make my definition distance to focus over distance to vertex. You know that the vertex is along the major axis. So if it's a short fat ellipse, then yeah, it's C over A. But if it's a tall skinny one like the last one we did, it would be C over B. The eccentricity is a measurement of each one of these conics. What do you think the eccentricity is for circle? What do you think? Well, I guess maybe I should ask you this question. How far is the center away from the focus on a circle? If you don't remember, then maybe I should show you the picture again that some of you didn't like. Okay? But we put the two together, right?
Why does it never go like?
So let me ask you a question. Those 2 points, which were the foci of the ellipse, are now together. What is the distance in that picture of the from the center to the focus. How far is the focus away from the center?
Oh, it's on the center.
Which would mean it is how far away from the center?
0.
0. Therefore, the eccentricity of a circle is 0. Okay? As you start to move away from it, you start to get a higher eccentricity. Anyway. Jump back to my notes. So keep that in mind. Distance to focus, well, we always call that one C. So that's not going to change. It's the one on the bottom that you have to pay attention to. It's the distance to the vertex. And it follows along the major axis. It could be A or it could be B, but it has to be the one from the center to the vertex. Okay. Now, we're not going to get into this next example, analyzing Earth's orbit. It's in the book, but after further review, I decided not to. We got enough other things to worry about before we get to the final exam. Okay, now, reflective property of an ellipse. Okay, now, sometimes they talk about a three-dimensional object in space. If you take an ellipse and you rotate it along its major axis, just imagine that. Take an ellipse in your mind. Look at the major axis, and then rotate the whole thing. You come up with a solid object. They call it an ellipsoid. Use that one at your next book.
It's an egg.
Don't you dare. Don't you dare. Okay? Oh my goodness, you people. Okay?
It's vegan.
Now,
Vegan.
look at what they're showing you in the picture. Okay, they're showing you, and it talks about if we place a signal at one focus, it would send that signal to the outside edge of the ellipse. It would bounce off the ellipse, and it would land at the other focus. This is an extremely important property of the ellipse. There is a building in Washington, D.C., can't remember the name of it right now, I forget which one it is, that has the elliptical shaped ceiling. Actually, I think it was the Capitol building, because I was actually in it this summer. Okay, so it has, okay, and here's the funny part.
Pentagon's not in Washington, D.C.
Listen to me. It's the Capitol building. So I was standing in this room, and we had a guided tour. Okay, and this is the point that the tour guide was trying to make. He said this is what came out of his mouth. Because the ceiling is parabolic, that's when I fell out of my chair, okay? I actually went up to the tour guide later, and I told him, that's not true. The ceiling is not parabolic. Whoever told you that it's not telling you the truth. It's elliptical. Okay? It's got a totally different definition. Besides, a parabola has one focus, an ellipse has two. So here's the interesting part of that elliptical ceiling. When you stand at one focus, and the other person is across the room at the other focus, they can whisper, and you can hear them because it bounces off the ceiling and comes straight to your ears. You have to be standing at those two spots, and the story goes that two senators didn't realize the ceiling was elliptical a long, long time ago, and they were talking about each other, and the other one could hear them because they were standing at that spot. Okay?
What did your guy say when you told him?
He wanted to argue, and I'm like, okay. And then, I'm sorry, it bothered me so much. I sent an email to the Capitol building and said, their tour guide and said, please. I said, the rest of the tour was fantastic, but please make him correct that.
That is
So
something a math teacher would do.
it really bothered me.
Really just block
It really did bother me.
You should have just like had an article in front of everyone, like right there.
I don't know if I can do this. Okay, let me see.
You have to go to that.
No, I'm going to. Yes, and I haven't opened that up yet. I didn't have a chance to. Okay, do we have to watch this whole commercial? This is a pretty cool commercial, though, by the way. Troy, that is not the video I was trying to. Okay, it was obviously. It obviously took the link from the commercial, not the link from the video I typed in. Okay.
So, Mr. Staley, you know what's going on to the right? What you been watching lately?
Because I feel like that. Okay.
Ever
So I want you
since
to pay
pool
attention
billiards
to this.
has
This
existed,
is an
mathematicians
elliptical
and
pool
physicists
table.
have had these thought experiments
have to.
about mathematical
I want you to
pool,
pay
mathematical
attention, not to
billiards,
the
because it's
commercial.
great for working out how
Okay.
a particle, or in this
All right,
case,
I want you
a
to
pool
watch
ball,
what he's doing.
will rebound
Okay.
against the sides
He's
and
going
where
to
it will go.
place,
So I thought, enough of these thought
the pool ball
experiments, let's
on
build one.
the focus.
The shape is
You
an
can-
ellipse.
That's one nice
And
trick. You
ellipses
can
are an
continue to
interesting
just keep
type of shape
following
because
the
they can
outside
come in an
edge,
infinite
but,
number of varieties.
not
The
all that
geometrical
creative.
property
Okay,
of
so
ellipses, which is why
if you place
I
it
have
on
made
the
this
focus-
table, is the fact that if you place a ball
So he's
on
placing
a
the
focus
ball on the
point,
focus.
wherever you hit
pocket- or
it,
the
in
pocket
whichever
of the pool
direction I
table
can hit
is
it,
also
over there,
on the
over there,
focus.
over there, over there,
So
over here,
what
it
he's
will
trying to show you
always
is if he's
rebound
got the right
into that
speed,
pocket.
it will
That is
not matter
because from any
whichever
point
direction
on the
he
side,
shoots the ball,
it
it
makes
will
the same
go
angle
to the pocket.
to each focus point. And as you
That's
know,
called the
when you
reflective nature of
rebound
an
something
ellipse.
against a surface,
So
the angle of
it won't
incidence
matter as
equals
long
the
as he's
angle
got
of
the right
reflection.
speed.
Whenever it is
Overshoot
positioned
or
on this focus
It's
point,
going to go
wherever I
no
hit it,
matter
it will
which
go
way.
in. You know,
Take
if it's
the shot.
here, wherever I rebound it, it's never going to go in. It's only when it's exactly on this dot.
As long as
And
he's
so that's
got
the
it
theory, and
sitting
that
on one
makes this really good
focus,
fun, and I will
then
demonstrate
he can
it.
pick whichever direction.
But obviously,
It will
I'm
not
a mathematician and I love things to be
That's
perfect,
what we're
but this
trying to
is,
get at.
we're in the real world, so now kind of
we went to the
annoying
trouble
physics
of
gets in the way.
designing
Things
this
like
elliptical
friction,
pool
things
table
like the
and
difficulty of manufacture.
Just for this cool video. Yeah.
You also have to hit it with just the right force. For example, if I hit it
So,
really
It won't
hard,
matter which way he shoots.
He missed.
it rebounds
Correct, 'cause he
to
didn't
this
have-
side of the
He
pocket.
didn't have the right speed.
If I hit it a bit softly, it goes to the other side of the pocket. So obviously, if there is the Goldilocks,
If he doesn't have it on the
the
focus,
one that's neither too
then it
hard
won't.
nor too
But it
soft,
will every time.
it should get it in.
If
And
he
let's see if
doesn't
I
have
can
it
do
correctly
that.
on
And
the
that's
focus,
it. If I don't
he
get
needs to have it on the
it's really
focus to make it
difficult.
happen.
So you've got to be very skillful. Oh, beautiful! It's so satisfying the way it rolls round, round and round.
Okay,
Just
now-
remind
No. I know.
Why didn't I already
Listen. What you see in front of you is a picture of an ellipse. From the top view, there's a person sitting on the left side. What we're doing, we're talking about something called a lithotripter. Now, I've never had this lithotripter used on me. I have had, please listen. I've had 4 kidney stones in my lifetime, but none of them have been larger than 5 millimeters was the worst. If you go to 6 millimeters or larger, you are not able to pass them. They either have to be surgically removed or they need to be blasted out with this device. Now, this is a non-surgical technique. What they're doing, they are perfectly setting the kidney stone at the point of the focus of the ellipse. Look, pay attention. The sound emitter is at the other focus. The sound emitter sends waves in all directions. And because of the reflective nature of the ellipse, every one of those waves bounces off and is directed to the other focus right on that stone. And it blasts it into little tiny pieces so they can be passed non-surgically.
Then you get a bunch of little.
Correct. And then you just continue to take the medicine until you pass them all. Okay? So this is how we use an ellipse to treat people. Okay? So the ellipse used to generate the ellipsoid of a lithotripter has a major axis of 12 feet. Okay? And a minor axis of 5 feet. How far from the center are the foci? Go, folks. Now, if you need a picture to help you, you could make a picture and center the ellipse at the origin. Make it easy on yourself. Okay? You need 12 feet on the major axis, 5 feet on the minor axis, and then find how far from the center are the foci. If you need to draw it out, draw it out.
Wait, how do we make a line?
They asked how far from the center are the foci. So, if you've got 12, then you have one of your dimensions was 6, the other one was 2.5. I don't care whether it was your A or your B. It really doesn't matter because they didn't specify. But I have 36 for A squared, 6 1/4 for B squared. I need to subtract them and take the square root, so 5.45 feet. I know some of you had 5.5. That's fine too. I understand. But that's what they need to do. They need to be able to calculate how far from this machine, or where they need to know where these foci are going to sit in relationship to this kidney stone and the sound emitter inside the lithotripter. Okay, so that they get it in the correct spot. Are there any questions besides the kid who hasn't watched the video from yesterday? I understand you do, so no problem there. Yeah, I think we're done with this. Yeah, I think we are. Homework. Ooh, let me go find. Do on question 9. Graph it.
Oh, yeah, I'm sorry. I tried to.
I don't care. I can graph it without their stinking
No,
graphs.
you had to match it to it. Yeah, you had to match it to one of them.
So, if you can't figure out which one it is after you look at my picture, that's sad. All right, so what's the center?
2, -3.
All right, so there's the first mistake that a lot of people make. They say 2, -3. Why is that a mistake?
It's actually, -3 too.
Oh, yeah.
And there's my answer.
They tricked you because they switched Y and X. Ah, those evil people. So how about A? What's A? Come on. Square root of 4, right? Which is 2. And how about B, which is the square root of 16? Okay, so now we got A and B. Stay with me. C, the square root of 16 minus 4. That's square root 12, but I didn't really need that because they were just asking me to graph it, right? Okay, so I need left 3, up 2, and it's got to be 2 units left and right, 4 units up and down. Oh, look, I'm going to run into my numbers. 1, 2, 3, 4. So it's going to be more of the taller, skinnier variety. Something like that. Which is whatever letter choice. It's obviously not C or D.
How did you get the? What is C equal again? I always forget.
C is the distance to the focus, which they didn't ask me about. I just did for kicks and giggles.
So how did you add 2 to the center? Like, isn't A no, A is left and right actually.
A is left and right.
So you went 2 left, and then you went. Oh, okay, now I get it.
Yeah. 2 left, 2 right.
Yes, because I thought
4
A
up,
was
4
on
down.
that. Okay, yeah.
Okay. Copy that. Take it back to the document.
Oh, I don't need the.
And paste. You don't need 19? Or
Yes, that's
Wait,
not
I
mine.
need
That's
19.
I meant.
Actually, I put it in, so it's not
Ooh, stealing thunder. Okay. All right, next. Ooh, they're trying to trick me here.
Oh yeah, that's why I plopped that sucker in there.
Whoa, this is a tad bit on the evil side, folks. All right. Some of you have difficulty with this because you just don't remember junior high. But you know, there's reasons for that. Yes.
Why do you call it junior high?
Well, actually,
It's because certain parts of the country call it that. All right. So let's see here. Right now, it looks like it's over 1. Right?
Wait, you forgot the two.
Oh, he needs to pay attention to this. I know. All right. Well, we don't care about that. Okay. We're working. Yeah. Hands. Listen.
Wait, where'd you put the 2? I'm confused.
All right. Okay. Just wait. Just wait. Okay.
Oh,
Since you want me to say middle school, I'll say middle school. Back in middle school, we learned that multiplication by 2 is the same as division by what? Oh. See, you had to make that change, folks. Okay? Now, if that's the case, then that means that A is equal to what? The square root of 5, and B is equal to the square root of 1/2, also known as radical 2 over 2. Interesting. Once you do all the rationalizing stuff. Sometimes. What's the center? -2. There's a reason you don't remember things when we get to test when you just ignore me. No. Okay, so are we okay on the center?
No, wait.
How did I get what?
How did you get radical 2 over 2?
Because I went square root 1, square root 2. I know the square root of 1 is 1. And then I rationalized the top and the bottom. See, we did that back in Trig when we were doing things like cosine pi over 4.
You got the center by looking at the 2 and the 1.
Okay, I couldn't hear the question. Hey, I could not even hear the question, and she's right in front of me.
I get it. I just thought you
All right, I thought there was a question, but seriously, guys, enough of the chit-chat.
It's back there. His hands.
Okay. What are they asking me to do in question 19? They want me to graph this? Okay. So -2 and +1, we know the center. Oh, I hate this.
What's a function graph?
I don't care. We can do it by hand. We don't need no stinking calculator. No, I don't need that, and there's no reason for it. Okay? All right, I need you to be able to find the pieces. All you're doing is going left to right, up and down, putting some dots and drawing an ellipse. Okay? How far left am I going? How far is radical 5 in the world of decimals? 2.25 approximately. Oh my goodness. Okay, we're over here. Okay, then 2.25 there is going to be just on the other side of the y-axis. And then how far up and how far down? This is approximately equal to what? What is radical 2 over 2? Approximately equal to 0.707. Thank you. All right, so not even 1 unit up. And not even 1 unit down. So we're talking a fairly small, I'm not even sure I can do this very well. Oh, man. I don't know. This drawing program is not my favorite in the whole wide world. Okay. I almost got it. Yes.
Was it 1 unit up from the origin or from the center?
From the center. Once you have to locate the center. Every time I've done this, the first thing I've asked you is, what's the center? You have to locate the center first before you can start saying, okay, left and right, up and down. What's the major axis and which way? I mean, everything's based on that center.
Okay, I appreciate that.
Yeah, good. They only asked me about that. Did they ask me for the foci at all?
Nope.
Nope? Okay, cool.
But you know, we can
All right, well, let's do it just for fun. C equals the square root of
-2, whatever the C.
Radical 5.
5 minus 1/2. A squared minus B squared, right? So we get the square root of 4.5. Boy, I'm going to have to reach for the calculator for that one because don't know that. 2.12. What are we going to do with that, and which way are we going to use it to find the foci?
You're going to go left.
Left and right, because the major axis is horizontal. That's true. All right? So from the center, we would be adding and subtracting to which? The x or the y? The x. All right? So if you, since I just want to do this really quickly, I'm going to say -2 plus or minus 2.12, comma, 1. That'll take care of it. If I actually ask you for the foci, nah, you could probably have actually figured it out. I'm just doing it to speed up the process today. Graph the ellipse using, okay, so they're just asking me to graph. We already did 19. Do we need to do 17?
No.
Okay, by the way, what's the center of question 17?
0, 0.
0, 0, which makes it even easier than any of the other ones. So, whoa. What's below that? Anything? Nope. Okay. Jump back to here. So the remaining questions for you, all the way through. Okay, you have to be more specific if you want something in there. What's going on here?
Remember when we did sine and cosine and we like did the same thing?
For geometry.
No, physics.
I am going to fail this final.
Don't plan on it. Okay, which question did you want?
Well, we only have a minute, so I'll just ask you when we return.
We just have to
Or
go
did you want
You need to
utilize
pick
this?
something.
Okay.
Oh, wait.
25? We already did that one for last night, huh? Did you?
Yeah.
Oh, okay, so you already know how to do it.
Graphed them, but I didn't know how to do it.
Oh, okay, all right, then we can do 25. And then I'll check your homework. And then 25, let's see here. Endpoints of the axes are plus and minus 4, 0. Whoa, don't do that. Let's see, rocket in place. Switch over to this. So we've got, why isn't it drawing? Oh, there it is. 4, 0, 1, 2, 3, 4, 1, 2, 3, 4. So is this going to be, which one's the major axis? Is it this one or is it the other one? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's horrible. Wow. Vertical axis scale. Ooh. All right. Which one is it? Is it up and down or is it left and right? It's up and down, even though it's poorly drawn. What's your center?
0, 0.
If it's 0, 0, then these numerators should be extremely easy for you to find. Out of 16 and 25, that's right, because A is 4, that makes this 16. And since B is 5, that makes that 25. What's it all equal? Hey, we found the equation. Now, for those of you who said that was difficult, does it make more sense now?
You remember 31?
31?
Yeah, is it just the 33?
You gotta go.
We only go 1 through 28.
It's 1 through 30. No, 20, whatever we did, it's 29 through 39. And there's like
A number 59, I
Yeah.
believe. Okay. And then there's another type of problem I want to go over with you, but tomorrow. Okay? So, that's enough for this video. We can do 31. Here, I'll clear this off. 31. Major axis endpoints at 1, -4, 1, 1, 2, 3, 4. Okay, so 1, -4, and 1, 8. Oh, man, it's going way off graph. Oh. Okay, so it's actually outside of my window here.
Simul, I heard you broke an umbrella while screaming at the top of your lungs.
Why does that have anything? So, what's the center? If you've got 1, 8 and 1, -4, what's the center? That's 12 units away. From 8 to 4 to -4, that's 12 units. So, where do I go to find the center? Wow, it should be halfway in the middle. Come on. 6 units in there. Yeah, 6 units up. That would put it right here at 1, comma 2. So, what should my parentheses in my numerators say? X minus 1 and y minus 2. Okay? Since the b value is 6, what goes underneath the y squared term? 36. What else did they give me on question 31? Minor axis length of 8. So minor axis length of 8 would be 1, 2, 3, 4 units this way. So that means my a value is 4. So what are you going to put under here? Yep, if a is 4, then a squared is 16. So just use your information. The picture helps you a lot. Okay, I'll come around and check your homework.